Welcome back, Algebra 2 students. Today we're going to look at solving some absolute value inequalities. We've worked with the equations where the absolute value is equal to something. Now we're going to talk about what if it's less than or equal to or greater than or equal to. So let me take you back to when we talked about we watched the video with the football player, and remember that we had that target right in the middle, right? And they put it on a number line. And at the very end, player 12 had a total of 14, plus he had one more ball to throw. And the player closest to him had 18, and I think the one above had 20. So this player 12, what did he need to get to win? If he had 14, his absolute value of his distances from the target was 14, and he had to beat 18. So we talked about that he had to be if he is at 4, he's 4 units from the target. If he is at -4, he's also 4 units from the target. So if he's at one of those, he ties. Okay, so he would tie at equal 4 or equal -4. But then in class, we had a discussion about where could that ball land for this guy to win. To win, he needed to be closer to the target than 4 feet. So anything in this whole range would have been a win for him because he's closer than 4 feet to the target. So we talked about that if his throw was between 4 and -4, between -4 and 4, if the football he throws lands somewhere between these, then he's going to win. Okay? Where would that football land that he's going to lose? If he's going to lose, if his total distance is going to be more than this 18, then he would have to be here or here. Actually, I wrote that backwards. This one goes with this. X is greater than 4, and this over here is X is less than -4. For those two spots, he would lose. So this, if we wrote it as an absolute value, his absolute value of X has to be less than 4. And for the lose part, his absolute value would be greater than 4. So what I'm going to show you today is to figure out how to solve these absolute value inequalities. What do we do when there's not an equal to, but a less than or a greater than? And you'll notice that, again, anything in between, if he landed that football anywhere between this 4 and the -4, he would win. If he landed exactly on the 4 or exactly on the -4, then he would tie. And if his distance was greater than 4, which could have been here or over here, then he would lose. Okay, let's look at some problems. And it's going to take me all the way back out. A little bit of patience. Okay, make this bigger where you can see it. So what does it mean when we're talking about absolute value? We said that the definition of absolute value is the distance from zero. So if you have an inequality that says the absolute value of x is less than a, that means that the distance from 0 to whatever your x value is has to be, if this is a, this distance is less, this distance is less. Notice the circles are open. If you have an open circle, you're going to be less than or greater than. If you have a colored in circle, it's an ugly looking colored in circle, you're going to have less than or equal to, greater than or equal to. Okay? This is called an AND problem, because it would be x is greater than negative a and x is less than a. They're connected. So it's in between those 2 points is where our solutions are. That's an AND problem, and it's going to be important to be able to determine an AND or an OR. Notice in this AND problem, we're shaded in between. It's like in the football problem, he could have thrown the football anywhere in here to win between those two numbers. Less than this one and greater than that one. And everything included in the middle. Look at this next one. It says x is greater than a, or x is greater than or equal to a. The only difference here would be a closed-in circle and an open circle. So if the distance between a and 0, or the distance between x and 0, the distance between x and 0 is bigger than whatever this number a is, then we're going to shade away from, because it's greater than, that distance is greater this way, or that distance is greater this way. That's an OR problem. So an AND is going to be a less than, you're going to shade between, a OR is going to be the greater than, and it's going to shade apart. Let's look at some examples. If my program will cooperate. I think it was cooperating. I was just zoomed way in. Okay, this one says solving the absolute value inequality, the absolute value of a is less than b. Muted that because I want you to listen to me and not to that program. It says, what is the solution of the absolute value of 2x minus 1 is less than 5? So whatever this 2x minus 1 is, this distance from 0 has to be less than 5. So let's think about, what does that look like on a number line? Here's 0. If our distance is less than 5, that means it has to be, that's what was throwing me off a while ago. I had that negative because of the football thing. Okay. If this distance is less than 5, it's going to be between negative 5 and positive 5. All these distances are less than 5. This is an AND problem because we're going to be shaded in between, right? Whatever this 2x minus 1 is, it's between the 5 and the negative 5. So how are we going to solve that? Here's what we're going to do. We're going to put the 2x minus 1 in the middle, and we know that it has to be between negative 5 and positive 5. You put a line underneath your symbol if there's a line under the symbol in the problem. In this case, there's not. Do you notice there's no line here? So we're not going to put a line in our problem. Now, this is like solving 2 and 1. This is called a compound inequality because there are 2 of them. And when we solve it, how do we get to x by itself? going to start by adding 1. I'm going to add 1 here, but I also have to add 1 here and add 1 here. So then I have -4 less than 2x less than 6. See what we did? We added 1 in 3 places. We're solving a compound inequality. Now, divide by the 2. Divide this side by 2, divide this side by 2. So then I have -2 less than x is less than 3. So these are all of the values you could use for x to make sure that 2x minus 1 is between 5 and -5. What did we do? We looked to see if it was an and or an or problem. If it's less than or equal to, that's an and. If it's greater than or equal to, that's an or. Okay. Some of you, I've heard you talk about alligator, and all that stuff. Less than or equal to. Greater than or equal to. You need to learn those. You're in Algebra 2, it's time. Okay, that less than, you can make a little L by it. You can, if you squash that L, it looks like a less than. The point of that arrow is pointing to the smaller number. All right, let's do another one. What is the solution of the absolute value of 3x minus 4 less than or equal to 8? Oh, you know what we forgot to do on the other one was graph the solution. That's okay, we'll graph it on. Can I go back? I bet I can't. Okay, we'll do it on this one. What is the solution of absolute value of 3x minus 4 less than or equal to 8? Is it an and or an or? Because I have a less than or equal to, it's going to be an and. So I'm going to put -8 over here, less than or equal to 3x minus 4, less than or equal to positive 8. This is the number that changes sign. It can be 8 or -8. Just think about your number line. If that distance is less than 8, it can't go past this -8, and it can't go past this positive 8. It would be somewhere in between there. Okay, how do we solve it? Remember, it's a compound inequality. Start by adding 4. The goal is to get the x by itself. Divide by 3. So we end up with -4/3 less than or equal to x less than or equal to 4. Where did I get 4? 12 divided by 3. Now, the other part of this is graph the solution. We didn't do that on the previous problem. That's okay. We want to graph these two numbers, the -4/3 and the 4. Here's 0. We're going to make 4 over here. -4/3 is a little bit more than -1. So let's make this 1, 2, 3, 4. 1, 2, 3, 4. -4/3, just past the -1. And the 4 closed in circles because there are lines underneath, and you would shade in between because it's an and. Right? Closed in circles if there's a line underneath, open circles if there's not. When it's an and problem, you shade between. If it's an or problem, you shade apart. Let's go back and look at that other one a second. I think I can do this and go back. It's going to make me get rid of that, so it's not going to save it. I tried. Okay, when we did this one, this was the first one we did. We didn't graph it, but we had 2x minus 1 less than 5. And we put a -5 less than 2x minus 1 less than 5. The less than tells me it's going to be an and problem, so I'm going to shade between. No lines under the inequality symbols mean I'm going to use open circles. And I added 1. And I divided by 2. This is the one we did previously. We just didn't graph it, so I wanted to go back. So then I have -2 less than x less than 3. When I graph this solution, because it's not just those numbers, but it's everything in between those two numbers. So here's 0, 1, 2, 3, -1, -2, -3. Open circle because of a no line under the symbol. It's an and problem because the symbol is less than, so I would shade between. Okay? That's an and problem. How do you know if it's an and problem? You know it's an and problem when it has less than or equal to. Okay. Let's go back here and go to this one. So we haven't done an or problem yet. An or problem is when your symbols are greater than or equal to. Here is one. It says the absolute value of 2x plus 4 is greater than or equal to 6. Now let's think about for a minute what that number line looks like if the distance is greater than 6. Greater than 6 is going to be over here or over here. It would be, for example, with our football player, he had to be 4 feet from the target or less to win that competition. If he had thrown it less than -4, like less than the -4 or greater than 4, he would have lost. Okay. When the distance is greater than, that's when your shading part's going to be split up. This is an or problem because it's this or that, but not both. All right. When we solve this one, we can do it the same way. Now, what would we do? Subtract the 4. Then we have -10 greater than or equal to 2x greater than or equal to 2. What's next? Divide by 2, divide by 2, divide by 2. And we end up with -5 greater than or equal to x greater than or equal to 1. Now, when you start to graph this one, when you look at this half of this compound inequality, that is -5 is greater than or equal to x, or if you read it this way, it's x is less than or equal to -5. So our number line, 1, 2, 3, 4, 5, closed in circle, and shade this way. I need a no longer number line. Or greater than 1. Colored in circle, shaded this way. There's our or part because the shading is split. This part says x is greater than or equal to 1. This part, if you read it from the x, says x is less than or equal to -5. If you know that because it had these symbols, these greater than symbols, it's going to be shaded apart, put a circle here, and shade apart. Okay? How do you know whether to use a colored in circle or an open circle? Whether there's a line under your symbol or not. Okay. Next. Where's 2 of 2? That was problem 2. Where's 1? Here we go. What is the solution of absolute value of 5x plus 10 is greater than 15? When you see that greater than, that tells you it's an or problem. Right? This is an or problem. So we know that 5x plus 10 is greater than 15, or 5x plus 10 is. less than negative 15. So we can write it as negative 15 greater than 5x plus 10 greater than 15. We still split this, change the sign of that number, keep the same symbol that we started with. Now, solve. Subtract the 10, subtract the 10, subtract the 10. (15 minus 10 is 5. How do we get the x by itself? Divide by 5. And we end up with an answer. It's negative 5, that's from here, greater than x, greater than 1. We had the same numbers. Okay, here's my number line. If I'm not good with the signs and symbols and all that stuff, I know that this is we decided this was an OR problem. Here's my negative 5. It's an open circle because there's no line. Shade it this way. Here's my 1, open circle, there's no line. Shade it this way. Okay. If it's an OR problem, you're going to shade apart. If it's an AND problem, you're going to shade together. All right. You see the correct answer? Boom. Oh, we did graph it. There it is. And those are absolute value inequalities. So now you'll have some practice. Good luck. See you soon.